Hey everybody, it's Mr. Richards here, and today we're going to be talking about states of matter. It is Monday, November 23rd, and we only have school on Monday, Tuesday, Wednesday this week because of Thanksgiving break. And I'm only going to be giving you new materials today, Monday the 23rd, so that you don't end up having to cram stuff in on Wednesday before Thanksgiving. Anyway, let's get started. So states of matter, there's a couple of things that you should definitely know about the states of matter. The first of which is that while we teach them to you as if they are very, very clearly solid or a liquid or a gas, and that at the melting point everything becomes a liquid, and at the evaporation point or the boiling point everything becomes a gas. That's not really true. It's a little bit more mushy than that. As we know, because we live in Minnesota, sometimes we can have snow or ice on the ground, and then it's about 33 degrees, and it doesn't turn into water, it turns into slush. Okay? So when we talk about the states of matter, just remember that they're more like strong guidelines for matter, but not, absolute rules. Because in fact, water as a substance can exist as a solid, a liquid, and a gas all at the same temperature. Okay, so that's just kind of a reminder. Okay, so here's our states of matter sort of picture guide. Okay, we have solid on the left, we have plasma on the right. Now, generally speaking, I'm going to ignore plasma because we really only need to learn about solids, liquids, and gases. But for those of you who really want to know, like, what is fire made out of, and what is lightning, and what is the largest amount of matter in the universe called, and we'd say, well, that's plasma. But on Earth, solids, liquids, and gases dominate. Okay, the other thing I want you to remember is that in this diagram, moving from left to right, we go from lowest energy to highest energy, or lowest temperature to highest temperature. And that's another thing that you should know, is that temperature and energy are like this. All right, they are very closely related. In fact, they're the same thing. So solids have a lot less energy than gases. All right, that's just how it works. Anyway, so on the left, we have our solid here. We have an example of a crystal, which is a great example. And in solids, the particles of a substance are usually stuck in place. Now, while they can vibrate back and forth, they're not free to move around, all right? And we've seen that in the simulation before. So that's a solid. Now, when a solid turns into a liquid, whatever temperature that happens at, we call it melting. Now, obviously, water or ice melts at 0 degrees Celsius, same as 32 degrees Fahrenheit, but steel melts at a much higher temperature. Okay, so there's different substances. Butter is another good example. Butter is a solid, generally speaking, at room temperature. You get a little bit warmer and it turns into a liquid-ish. Anyway, so yeah, solid turning into a liquid is called melting. If you go the other way, liquid turning into a solid is called freezing. Okay. Now, if we move up and we look at the the particles of a liquid, they're still very close together, but they can slide around. Okay, if you think about a super packed room of students where there's not a whole lot of room, you really can't get away from each other, but you can move around a little bit more easily. So the particles in a liquid can slide around, but they stay really close together generally. Now, if you move from a liquid to a gas, we're going to call that evaporation. Okay, you could also call it boiling. But in general, we call it evaporation. And when a gas moves back into a liquid, we call it condensation. Okay. Now, in a gas, the particles of a substance are pretty much free to move wherever. Okay, they're kind of like kids on a playground. There's way more space. Kids generally don't stay super close together, and that's pretty much the same thing for the particles of a gas. They spread out. They can move around pretty freely. There's a bunch of other things about gases, like, because they're so far apart, you can actually squish them closer together, and we call that pressure. You can also spread them super far apart, things like that. So yes, gas. That is definitely one of the highest amounts of energy you can have in a state of matter compared to a solid, which is really low energy. The particles are much freer to move around as a gas than they are in a solid. Now, if we talk about plasma, and this is kind of like if you want to tune out, this is kind of like our level 4 sort of thing. If you want to talk about plasma, Some really interesting stuff happens to the atoms of a substance in a plasma. For a solid, liquid, and gas, the atoms all stay pretty much exactly the same. The only thing that changes is how they move around. But in a plasma, the atoms start flying apart and get like thrown out into positive and negative particles, all right? And that's what a plasma is. Now, the thing about plasma is that it is a change in state, and I use air quotes with that one because, since we're like breaking particles apart, you know, could you argue that it's not really the same substance? Yeah, you could. Anyway, we have positively and negatively charged particles that have been given so much energy that the atoms themselves are kind of flying apart. And that's where really cool stuff happens. Like the very edge of the flame and fire is an example of plasma. Lightning definitely creates plasma. It actually splits certain atoms apart. And then most of the dark matter in the universe we think is plasma as well. All right, so to move from a gas to a plasma, we call that ionization. To move from a plasma back to a gas, we call it deionization. That's pretty much all you need to know. Now, there is a third kind of transformative process where you skip the liquid phase and go right from a solid to a gas. And that would change this kind of linear diagram into more of a triangle diagram to allow you to go straight from solid to gas. And when you go from a solid to a gas, it's just called sublimation. It sounds pretty rare, but it's actually very, very common. For example, anything that has a smell. For example, if you make fresh brownies, you can smell them, and that is because the solid of the brownie, some of those particles are actually sublimating, turning into a gas, which we smell. Of course, farts are a much more disgusting example of exactly the same thing. Anyway, so moving from a solid to a gas is called sublimation. Moving from a gas straight to a solid is called deposition. And those are things that you probably should know, but it's not as important as just remembering the melting, evaporation, condensation, freezing kind of thing. All right, so that's your states of matter.